Hi everyone, welcome to this complete tutorial on Pandas, the biggest power of house of data analysis in Python. Right. So before we jump into code, let us take a step back and understand why Pandas matters and what you will gain from this session. Think about the world we live in today. Every click on a website, every transaction at a store, every sensor reading from a smart device, everything generates data, right? So but raw data by itself is just a messy collection of numbers of text. The real value comes when we organize, clean, and analyze that data to find patterns, answer questions, and guide decisions. This is where Panda shines. So Panda is an open source Python library designed to make data handling easy and intuitive. So imagine you have an Excel spreadsheet with thousands or even millions of rows. You could filter, sort, and summarize in Excel, but it quickly becomes slow and repetitive. With Pandas, you can do it. You can do the same task and far more complex one in just a few lines of code, and it scales beautifully. During this tutorial, we are going to build a strong foundation and before we get started, we will learn about the two core objects in Pandas, that is series and data frames. So, which are the building blocks for everything we do. So, reading and writing data, importing from CSV, Excel, or even database. So, we will also try to import CSV file and we'll do some uh, calculations and as well as do some coding part with CSV file. We'll look into it in the video and just stick with me guys and let's just learn. Okay. So let's start with the code. Now, okay. So I'm using Google Colab. If you guys are new to Google Colab, I've put one link in the description where you will get to know how to use type the Google Colab within 3 minutes, and it's pretty simple and it's not going to be a huge burden. Just a simple task that you will get to know what's the use of the Google Colab and why we use Google Colab and everything. So just go to the video and start the Google Colab. Now, so let's start with importing Python with Pandas library. So to import Pandas library, just type import Pandas as py. So this will import Python, PB. This will import Pandas as PD, and using PD we can able to access all the elements in Pandas. Okay. Since we are using Google Colab, every libraries will be installed. I mean, the most of the common libraries that everyone use will be installed in Colab. So there is no need of installing or typing pip install pandas or anything like that. It will be defaultly installed. Even the update will be done defaultly. So that's the main advantage of Google Colab. So if you are using other compilers uh, other than Google Colab, so before importing pandas, you have to install pandas library. So to install, we use pip install pandas. So using that, we can able to install panda library into our system. So as you can see, the Colab already have met the already met the requirements and satisfied the conditions. So now let's just import the pandas SP. Okay. So after this, let's just try to see what version that we are using. PD dot double underscore DE or version, and we're using 2.2.2, which is the latest version of its current date. So yeah, there are two types of objects that you can find in pandas, that is series and data frames. So let's just start with the series where you will do or you will perform some operations on the dimensional array. So first we need to get some one-dimensional array, right? So now let's start the series part first. I'll take one dimension. That would be more helpful. So I think it is just right dimension. Okay. So let's create a one-dimensional array or the list using data equal to I'll type 100 comma 22 comma 20 comma 30 comma 48. So these are the one-dimensional array that we can find, and I mean that have given. So now the part is we need to feed this data into the pandas series library. So to do that, let's just define a variable df. So ad dot use the capital S because we are using constructor here. Series data and print df. For this, we'll get a linear index wise as 100, 202, 20, 30, and 40. So now these are 0, 1, 2, 3, 4 are the index values, and 100, 202, 20, 30, 48. These are all the values of corresponding index value. So you can also try, change the index values to alphabet like INT equal to. So I've given a B, C, D, E as a characters. So let's just run this. As you can see, the index values changed from A, B, C, D, E, F. So this is how we can change the index value, or you can also give it in range. Like if you want to start our indexing from 1, you can type 1 to I think it's 8. Okay, we can't give an appropriate size. We have to make sure the size is proper. 3, 4, 5. So it's 5. I will give it as 6. Just give it some seconds. Okay, just this one. Okay, like let me give a range from 1 to 5. Let's see how it works. I'm sorry, it should be 1 to 6. It will start from 1 to 5, and this is how we can change the index of the array, or we can also type like end of data. That's what it will also work. Anyway, so now if we change the data type of the values which are in data, just like this, and if you run it, as you can see, the data type has changed from int 64 to float 64. So just give me a second. Nice, saved successful. Now you can also get this data using a simple command, that is df of 1 get np. As I said, like pandas are basically built on top of numpy. So that's why the data sets are stored in the form of numpy, and we are the data set is float 64 and the data that is 100. So the index is 1, the value of that corresponding index is 100. So this is how we can get. And one more thing, there are also other ways that we can find the corresponding data, but we'll go to the two-dimensional array because this is all that I can give you in one-dimensional array, but two-dimensional array will be a more hectic task. So let's just see that. So here we'll use data frames. constitutional. So yeah, let me introduce a new dictionary as name, which values corresponds to uh, suppose the first name is John, that the first letter is J, comma Sam, Randy, some random names, okay. So and their corresponding age will be 30, 33, 26, some random age. And what else can be? Let's try to print this using data frames. So let's try to build df1 and pd dot data frame. So make sure that you call uh, data frames in capital letter of D and F because we are using constructor. So now let it be data, and let's try to print df1. Yeah, this is how we get like 0, 1, 2. And one more thing, if you want to add another column, suppose like what are their occupations, or we can do that as well. So just type df1 of, let it be job that they do, equal to, suppose John occupation is an engineer, and Sam is a doctor, and Randy is a famous chef. So let us relate to this. Yes, as you can see, we have added another attribute, that is job, engineering, doctor, chef, capital D. Okay, we can also add rows or introduce new people as well. To do that, let's create a new df1. So here we will add df, so pd dot data frame, where we'll add a new dictionary here. So name it as uh, name, and the name corresponds to Ruby, and his age is 32. His current occupation, I mean the job is a driver or a racer basically. So we need to concatenate this new df with df1 with the df. So to do that, df1 equal to pd dot concat df1 with new df1. Now let's just run this. Okay, just give me a second. Since we are doing this, we have to make sure that this is all in column. Yeah, you can add even more number of libraries over here, but just like put comma and add a new library, and you can keep going on like that, but it's not limited to just one. You can add a more number of people according to wish. So we can also change the index value from 0 1 to here's the thing, we got 0 here, right? So we need to change this index value from 0 to 3, I guess, right? So to do that, put comma index equal to, we start with uh, df1 dot, so then of df1 and run it. Okay, this should be in a list, right? This should be in a list. Okay, we got the three. It's time for CSV file extraction. So to extract the file, have downloaded as CSV file, that is from Kaggle. So from here I have downloaded the dataset of the Pokemon that I'm going to use. So this is a 44 KB file size. I will be giving you the download link in the description. So no need to worry. So what you need to do is you just have to copy and paste the file over. Just click on this folder and just copy and paste the Pokemon.csv file over here. So that's the only thing. Let's just try to extract this CSV file into data frame. So to do that, df is equal to d dot read CSV. Type the Pokemon name, I mean the file of the name of the file, Pokemon.csv, and let's just print this df. So right, so we have a lot of things to take care, right? We have 800 rows and 13 columns. This will be our index, and this will be our default index, which comes with the uh, we can also change the index to this, right? So what we can do is, so actually we can change the index value to this hashtag. So let's just make that index equal to I mean we need to pass it as a string. So let's just do that, and yeah, right. So this will be our index now. As you can see, we have eliminated one of the rows. So now we have 12 columns and 800 rows. Okay. Now we have lots of things here like Bulbasaur, which is a grass type Pokemon, and a poison type Pokemon. And total HP, or I mean total power is 318, HP is 45, attack is and speed attack. So all the things that we can see. So now, as you can see, some of the data are emulated over here, right? So we can also get those data just like it's not emulated, but it's not showing up, right? So to do that, print df dot to string. So just type this, and you will get the complete data. Right. So there are some of the legendary Pokemons. The only thing is that handling this kind of data sets with lots of values printed on the screen is somewhat difficult. So we have lots of legendary Pokemons and generation that these Pokemons are. So let's just try to do some analysis on this data and try to get what we are looking for, right? Now let's just remove this, just type df, a simple one. Get to know what are the things that, right? So if you want to print all the leaves of the data frame, just open the square bracket and type name, and you get all the names, right? So this is how you can do it. And if you want to print multiple things like suppose if you want to print name and type 1, type 2 simultaneously, you have to print, have to open two square brackets and type name comma type 1 space 1 type 2. So now if you get all the types, so we have prop type, poison type. So here in Google Colab, you can also get a graph just by clicking this. Some time. It just let's let it analyze, or sometimes not prompt key. Yeah, so the graph that we get. Right, so let's just run this again and try to get the graph. Since we are using very large data sets, the values will not be printed accordingly. So let's just try to do something else. Okay, I mean the chat will be not printed exactly. So let's just try to do something else first. Now let's just change this index column with names. So we are making name as an index now, and just give it again. Can't print name again because we will not get name. Right, so name will be our index value. So now if we can extract data, suppose if we want data of a bulbasaur, right? So just open bracket bulbasaur, make sure I'm making sure that my spellings are correct. Okay, I think my spelling is wrong. Just give me a second. Oh, I made a mistake. I need to give locate. Okay. So now click on this. I think the name is wrong. Yeah, here we go. So you need to type df.locate bulbasaur to get the bulbasaur's uh, right. So bulbasaur's type. So we can also give multiple names over here. Get multiple. Actually, we can compare with the two Pokemons that we can like. Let's just take Pikachu. Let's be sure the spellings are correct. Pikachu. Right, we got Pikachu and Bulbasaur, and Pikachu is an electric type, and type 2 is nothing. Says it's nothing. So tutorial Pikachu is more stronger than Bulbasaur. This is what it's saying. HP is attack, defense, speed, generation, legendary. So that this is what we can get. Like we can compare the two Pokemons like this. Suppose we want to print only total HP, attack, and defense of Bulbasaur, and let's just try to print for Bulbasaur once, right? With brackets. In Bulbasaur, we are trying to print HP. It's a string, right? Yeah. Let me print total. Total, comma HP. Both are sorry. HP and attack and defense. D is capital. Now I just try to print this. Defense is not in index. I think I did a mistake here. Just give me a second. TPMC. S, right? So I'm thinking this is right. It's fine. Get the we'll get the details of Bulbasaur with only HP, attack, and defense. So if you want Pikachu also, you can get that. I don't know. I'm just trying Pikachu. I think right. So we got Pikachu and Bulbasaur with only total HP, attack, and defense values. So this is how we can analyze. So we can also get the graph for this, right? Lots of graphical representation. So let's just keep it simple. Now the next thing is, so now let's try to make some beautiful code here, right? So first thing, what I will do is I will make a user to enter the Pokemon name that they want, right? So like Poke equal to input, enter the name of the Pokemon. Okay, let it be that, right? So let's just try df of Pokemon. Okay, sorry, POK. Okay, and we need to look at this and we need to print this, right? So we'll also try to will I try to do some expect value. So give us x c e p e and print f Pokemon not found. I mean the Poke is not found, right? So let's just run this. Let's try to this Bulbasaur's name over here and enter. So we'll get the details of the Bulbasaur, crash type, false, and this data type is object. So now let's just try to put something like some random values. Just give us I just press no. Yeah, some random values and let's enter. You get this is not found, right? So just experiment with this data set that you can do lots of crazy things with this the pandas and let's just go to the next part. So now let's just try to get data like first I will type just here. So we have lots of things over here like attack value, defense value, HP values. So let's just try to get whose HP is greater than 50, right? So let's just do that, right? So let's just see what is that attack, right? So this is the uh, column name hitting attack which is greater than or equal to 50. So let's just print this. So we have Bulbasaur, Venusaur, uh, Ivory, So that's what like we got purpose or false. Ivory is true, 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 and this is what we get. So we need to print that, right? So let's try to print that, and we'll get okay. Like we are, let's try to create a new data frame with this and try to print that one. Right? So let's just write f1 equal to f. So it's a df of df. Let's just enclose this and let's just print df1. So that's what we'll get all the I mean the attack value which are all greater than 50. We get all these details and whose attack values are less than 50. All those datas have all been eliminated. So let's try to find what are all the legendary Pokemon that we have, right? Legendary Pokemon which is equal to true. So let's just see legendary, right? Okay, equal to true. So that's actually equal to 1 or equal to true. True, right? So we can do that and we'll get the values. So there are over 65 Pokemons, not 65 exactly, 52 forms of Indian matters. 63 legendary Pokemon, that is Articuno, Zapdos, Moltres, Mewtwo. I have seen this Mewtwo, it's a very interesting one. So now let's just try to print uh, where that with the type 1 and type 2 where we type 1, let's just make sure that the type 1 is a water type or let me see poison. Let's make it a grass type and let's just try to print it. We got grass Pokemons and now it's very interesting and we have type 2. Just give us a second, let's just give it a space. Let's just make sure this one properly black and if type equal to water. So I have to close this bracket now. So this will be equal to right. I think there aren't any, right? Let's just type prop and see. Yeah, there aren't any Pokemon that are like type 1 is grass and type 2 is water. So let's just print type 1 is grass and type 2 is poison and let's also print like type 1 is water and type 2 as water itself. There are no such things. Okay. Type 2 as ground. We have a lot of Pokemons which are all with type 1 as water and type 2 as ground. So we can make a deep analysis and we can see there are like 5, 6, 10 such Pokemons that we can see. So we can do or over here and we get even more data, right? So we get what are all the type one, I mean type one which are all with the water type, and type two which are all with the ground type. We'll get all those data like this. So now let's move to the next part. Now let's try to do some mean mode or something like that as aggregate functioning. So aggregate function. Now, so let's just try to find the mean of all the numerical values that we have, right? So df dot, and if we do this, we won't get any values, right? No. So now let's just type numeric only equal to true, right? So let's just do this. Numeric, right? Why did it work? Nice, yeah, we got to the average values. As you can see, legendary generation speed, we have average, I mean the mean of 68, defense we have 71. So you can see, and also we can find minimum. So total, I mean the total minimum we have is 180, and HP equal to 1, attack equal to 5, defense equal to 5. uh, wow, and that one is legendary. Nice. Now let's try to think. So yeah, this one is also legendary, right? We have a total of 780. So let's just find out what are the Pokemon that are all with the legendary one, right? Let's go to me. I think HP was one, right? Me. Right. So TF1 equal to TF, where TF of HP equal to equal to 1, right? TF1. Oh, my apologies. It should be square brackets. No. Chandija, which is the one of the most HP equal to 1, and it's generation 3. We are also weakest Pokemon, and we have total power which is equal to 720, I guess, right? 720. So Arcus. Now let's talk about some keyword. You can get all the sum values like such as print dot count. Now after this, we get all the count values where we have the complete value for every columns, but for type 2 we have only 414 readings, because as you can see, so there are lots of Pokemons which are all not of type 2 kind of Pokemons which doesn't have any kind of type 2. So this is what we need to filter out this type of kind of Pokemon. We can do that. I'll show you later. No. So before that, let's talk about most important thing that we can do with data frame, that is grouping, right? So grouping. Okay. So to group the data frame, let's just try like group is equal to pd dot group, where actually we are grouping the data frame, right? Not pd. Like we have group by pdf group by type 1. So by doing this, equals to now after that, let's try to find the mean. Dot mean mean numeric only equal to true. Now after doing that, so we have type 1, that is bug type Pokemon, where we have details of uh, total. We have this HP, we have this, so we can say what are type Pokemons we have. Yes, we have grouped our dataset and find the mean of that particular group, right? So this is what we are doing here. We have grouped all the bug Pokemon and find all the uh, mean value of that particular group of bugs, and similar to every Pokemon, every groups. So this is what we have done, and there's also another way to extract only one particular group. Let me show you how. So let me show you how to group data. I mean, how to extract only a uh, single mean. So group of height or HP dot mean. Right, so we'll print this. Now let's just print this, and yeah, we have all the uh, means of all the HP for every group of Pokemon type, every type of Pokemon. So this bug have, and the largest one we can see is that normal Pokemon have 77 type, 77 mean, where we have huge HP for normal type Pokemons. So this is how you can analyze the data. Where I forgot to mention the sum keyword, where you can use sum. So using sum, you can able to get the complete details of the bugs. I mean, complete HP of the bug, and for normal we have 75,000. Sorry, 7,573, and this is how you can get the total HP of each group. So now the next part is data cleaning, right? So we basically use Pandas to clean our data. Let's start with the cleaning part. We use Pandas basically to clean our data, like deleting columns or rows, or deleting inappropriate unwanted data from the data frame. So we basically use Pandas. I mean, 75% of the cleaning is done in Pandas. So Pandas plays a very important role in cleaning data. So now let's try to print the data frame, and let's try to delete one of the columns. Like let's try to delete this generation column. To do that, df dot drop column equal to let's say I want to delete this generation, right? So right, so the generation column has been dropped, right? So in order to do that, we can assign it to some other like df1 equal to df dot drop, and let's try to print df1. And now in df1 we have the same data frame, but we won't be getting any generation column over there. So this is how we can drop a column in the data frame. So you can also drop multiple columns. Just if you need to, let's remove the attack column. Right, so the attack column has been deleted. Yeah, this attack column has been deleted. So you can use this drop command to delete multiple columns or single columns at the same time. So the next one, yeah. So now let's try to remove the null values which are present in the type 2. Like I am trying to delete all the rows which contains type 2 as none. So we can do that. Just type drop an a from subset where type 2. So what this do is like it finds whether the rows corresponds to null in type 2, and if there is a null value the rows will be get deleted. So let's do that. As you can see, there are no null values in type 2, and the column size also, I mean the row size also has been decreased, right? So 4 and the initial was 800 rows and now it's 414 rows. So this is how we can remove the null values. So as I said, we can remove the null values, but we can also replace the null values by typing replace NA, right? So we can replace the null values with fill NA. So what we will do here is, so we need to call a dictionary to fill the null values. Suppose like we need to fill the null value which are present in type 2, and what I'm trying to do is, suppose just click this, and we got 800 rows, and we have, right. So to replace the null values, df1 equal to df dot fill na. I will call a dictionary over here and try to fill all the null values which are present in type 2. Sorry, yeah, in type 2 which are all filled with an nan. I will try to replace with the type 1 fire itself, right? So I'm just giving them 5 and 5, same type as type 1. So do that, type 2, and replace with it df of type 1. So if you do this, yeah, I need to print it, right? So df1, yeah, null value of type 2 is filled with the values which are present in type 1, right? We can change the values like this, and we can also put other values like not in, not valid, or something like that. Yeah, the null value will be replaced with the whatever the type that we give here. So now the next part, Now let's try to replace some of the values over here. Like I want to replace this grass poison with something else, right? So I can do that. To do that, so we need to give replace uh, keyword. So suppose like df is equal to df of type 2, equal to df of type 2. So we can replace the values. To do that, let's type df of type 2 equal to df of type 2 type 2 dot replace. We need to call the dictionary over here, and let's try to replace the dark with in the dark with black, something like that. So I think let's try to print this. Right, so black, we got the black. So now let's just keep the dark as it is, and okay, we need to change this black to dark, right? Black to dark. Yeah, we got dark again. So this is how we can replace the values. So yeah, we are just replacing the dark values of type 2 to black, right? So and they can be replaced back to the dark itself. So this is how we can replace the values. And also you can do it for multiple if you want to change multiple datas over here, like you have to change this goes to dust or something like that. Ghost to dust. So you can do that, right? And you can replace this black with dark, ghost with dust, and grass with leaf, something like that, as you can see, right? So ghost is replaced with dust, so that water. Okay, that's what we can change the values by using the replace command. Now suppose we can, if we want to replace this capital B with small b, so we can do that just by, let's just say name, and name, let's do str dot lower and see what happens. Once again. Alright, so we have made our name as index. So let's try to do with type 1. Type 1. Type 1. Yeah, you can see that grass capital G has become small g, and capital F has become smaller. Sapphire. So we can see the changes over here. So this is how we can make it lower, and also we can make it upper as well. Uppercase. So everything will be upper now. So that's how we can do it. Lower. It should be smaller. So now one more thing, like we can see that these are all false, true, false, true, false, right? So we can make this as boolean as well. Like let's just change this type from legendary, legendary, sorry, and this one also with legendary. And I want to change this type to full dot as type as bool, right? So we can do this, and we can see, just give it some time. Okay, this is not initially bool, right? So let's make it int and see. Say, I hope this works, right? So we can see that we got 0 0 and 1 1 1 1, right? So let's just keep it as bool itself. Small p over it, right? So this is how we can change the type. Now let's talk about removing the duplicates, which is one of the most important keyword that we use. So to do that, df equal to df dot drop duplicates. Sorry, du duplicate under bracket, right? So let's try to find df. Right, what is it? Oh, it should be as duplicates. Right. So we removed the duplicates and we got 798 rows. So initially we had 800 rows and two of the entries were duplicated. So we have removed the duplicates also. So this is how we can remove the duplicates. And I think I have covered pretty much everything. And I hope you learned something new from this video. And I hope all of you enjoyed this session. So thanks for watching. Stay tuned.